So tonight I'll be talking about the night sky. I'll be talking about the planets just generally and how far away they are. I'll be talking about a few stars, probably some of the ones that some people may have heard of, and they'll be visible when the sun goes down later. And also a little bit about our galaxy and some other galaxies, and all the way out to just how big our known universe is. So if we all start off with the Earth, and if we shrink the Earth by 30 million times, we get a globe about this big. It's about 400 millimetres in diameter. Now I've got a number of other planets and other scale things that are at the same scale as that, so you can compare some of the objects to the Earth to see how they compare in size. Now the Earth itself is about 12,700 kilometres across, and once around the Earth is around about 40,000 kilometres. So London, that's on the other side of the Earth, is around about 20,000 kilometres away. If we shrink the Moon by the same amount, about 30 million times, we come up with a sphere about that size. You can see how small it is. I'll turn Australia around because, well, you can see how small the Moon is compared to the Earth. Now, a good way to remember how big the Moon is compared to the Earth, it's about a quarter of the size, so about 4 moons roughly fit across, or it's also about the same size as Australia. So when you look up at the Moon tonight, from one tip to the other, it's about the same distance, like it's almost in a perfect straight line at what they call the terminator, which is between the light bit and the dark bit. And that length there is about the same distance as from Sydney to Perth. So when you see a full moon, even though you can blot it out with one finger, your index finger or something at arm's length, it's actually about as big as from Sydney to Perth. So it's quite large. Now at that sort of scale, anyone want to guess where they think the Moon would be in distance? Like, is the Moon here? Is it where the projector is? Is it way out, out past that big tree out there? Or anyone want to have a guess? The kids are usually the ones that want to put their hands up. Anyone want to have a guess? Is it in this room? Don't all put your hands up at once. There's so many people. Yes, some adults.
It looks fairly close, so I would imagine it's halfway between the projector and...
So you reckon the Moon's around about here at that scale? Anyone else want to have a guess? Yeah? Right, just on the other side, about twice as far as what the other person guessed. Okay. Now, we can have a volunteer. Probably a child will come up. Not many adults volunteer for this. Anyone want to do it? You're the closest. Take this ribbon and just, got it? Just walk around the chairs and keep walking over towards that door. Right, this ribbon, you might have to lift it a little bit, otherwise we'll chop the heads off a few people. Keep walking, keep going. Right, this ribbon is about the... Keep going until it goes tight. Keep going, you're nearly there. Right, I'll pull this up to here. Right, that's how far the Moon is away. So it's basically just outside the door at this sort of scale. So you can see it's a long way away, considering every time you go this far, that's Melbourne to Sydney to Perth in distance. So you see, you can come back now. Right, I'll try and keep this up above everyone as we go. Right, so you can see how far away it is. Right, that'll do, thank you. Hopefully my wife will come in later and she winds this up. It's even more fun with one of the other things if we ever unroll that. Right, so if we were to measure out, it's about 12 metres away in distance. So you can see here, I went down to a park. This was before the drought finished, as you can tell. This park is now very nice and green and doesn't have any bald patches at all. So it's about 12 metres away. Now, if anyone has seen the moon tonight in some of the telescopes or at any other time, the first thing that you notice about the surface of the moon is it's covered in craters. The biggest crater on the moon is about 360 kilometres across. So it's big enough. The biggest crater would go from Warragul to about Ballarat, roughly in size. And of course, these craters are created by meteors that have impacted the surface of the moon. Most of these were created perhaps 3 billion years ago. So they've been there a long time. But because there's no atmosphere, they don't get eroded away. There's no wind and there's no rain. So most of those craters have been there for billions of years. And as these rocks have hit the surface of the moon, they throw material up into space and it falls back onto the surface of the moon and creates this crater shape that we all sort of come to recognise. Now, if you hit the moon with a large enough rock, some of that material may be thrown so fast that it actually escapes from the gravity of the moon. It reaches escape velocity. And so it'll go out into space and just continue to float around in space. And because the Earth, it might be a fair way away as we saw here, but because it's relatively close, and it has a lot more gravity than what the moon has, the Earth might pull some of these rocks that have been thrown up from the moon by a large impact at some time, and perhaps they might land on the surface of the Earth as a meteorite. Now you might think that's pretty unlikely, but we have actually found meteorites that have come from the moon. And this little piece of stone, it's about the size of your fingernail, less than 1 millimetre thick. That's actually from the moon. The first meteorites from the moon were found in the 1880s. So nearly 100 years before they went to the moon, they found rocks on the moon, but they didn't know where they came from. They knew they were somewhere special. They weren't normal meteorites, they were different. They had different chemistry and stuff. And you might wonder, how do we know that piece of rock is from the moon? Because we went there in 1969, a long time ago now, and they brought back rocks from the moon. And when they compared the chemistry of these rocks that they brought back, right, the first one that landed there, of course, was Apollo 11. And this little piece of, what looks like a little piece of alfoil from an Easter egg or something, that little piece of foil is from the Apollo 11 command capsule. So that didn't actually land on the moon, but that little piece of foil was on a spacecraft that went around the moon. And because we brought those rocks back, we could confirm that the chemistry of these meteorites is exactly the same type of rock. Yeah?
Can I ask questions while you're talking?
Yeah, you can ask. Try not to ask too many questions. Sometimes I get inundated, but any casual questions throughout the talk, feel free. Otherwise, you can come up at the end, and of course, you can have a look at all these bits that I'm going to show people as well.
I was just going to ask, are they from your personal collection?
Yes.
Do you have more?
I have a number of meteorites. If you want to buy a piece of the moon, everyone asks, how much does a piece of the moon like that cost? It's about $200, right? As you can imagine, something like that is pretty rare. It's worth 50 times its weight in gold. So a little piece of gold like that would cost you about $4 or $5. But that little piece of rock is worth about $200. But you can buy it off the internet, just don't buy it off eBay, because it's guaranteed not to come from the moon. You can buy it from meteorite dealers, and you just do a Google search and you'll find them. And they're actually certified meteorite dealers, and it's guaranteed that that will be from the moon. So that's how come we know that these meteorites that we've found are actually from the moon. Now the sun, of course, is the centre of our solar system. And all the planets revolve around the sun. And the sun is a star, just like all the stars that you'll hopefully see tonight. Hopefully lots of them. They're all basically great big balls of hydrogen. And the sun is much the same, its average, there's nothing special about it. All of our planets revolve around the sun. But how big is it? If we were to have, and I don't have a scale model of the sun, if we were to have a scale model of the sun here, how big do you think it would be compared to this? This is 400 millimetres across. Now the sun is at least a metre, I can tell you that. So the sun is at least this big. In fact, it's at least this big. And I want to guess, like, would the sun be a ball out to how far the moon is? Would it be half that size? Would it be way out beyond the tree, just in metres maybe, or, yeah?
5 metres from one side to the other.
Yeah? Anyone else? So basically about the size of this room, a ball about the size of this garage.
Like really, really far, down
1,000 metres.
That may be a kilometre. Some stars would be, actually. Our sun isn't. It isn't that big, but it is pretty big. If I was to have a scale model of the sun here, it would be 45 metres in diameter. So it would be a ball 4 times the diameter of this shed. So it would extend from here out over the car park, past where that little road is that you came past. You imagine a ball that big. That's how big the sun would be. You can see the distance, here's little me, the distance from the Earth to the moon is about a quarter of the size of what the sun would be at that scale. So it's pretty big. How far do you think it would be? Like, would it be, it's 45 metres in diameter, would it be a kilometre away? 100 kilometres away? Like, would it be in Sydney? Anyone want to have a guess? About a kilometre away? Yeah, just in distance. Yeah, how far?
East of Benalla Airport.
Not quite. One more person? How far do you reckon?
5 metres.
5 metres. So about half the size of this room. Well, like the moon, right, we measured out the distance to the moon, but we don't actually have time to measure out the distance to the sun. Because my wife doesn't want to roll this ball of string up for a start, and I'm sure it would get knotted in the process anyway. So we won't be measuring that out, even if we did have a volunteer. So at this scale, it's about 5 kilometres, 4.9 kilometres away. So it's somewhere in, way past Craggy's Road. Right, so long, 5 kilometres, a long way away. Now, but just recently, this is about 2 years ago now, they measured the distance to the sun very, very accurately, as you can see. It's 149,597,870.696 kilometres, plus or minus this much. Right? So they've measured the distance to the sun to within about 100 millimetres. But every year we get this much further away. So the Earth is slowly getting further and further away from the sun, but only by this much. And this much in 5 kilometres is not very much. And they think the main cause of why the Earth is slowly pulling away is basically the friction from the tides. As the tides are rubbing on the surface of the Earth, they're gradually slowing the Earth down, removing momentum, and as the Earth slows down, it'll gradually pull away from the sun. But it's not going to save us from global warming or anything like that, because the sun will be dead before we even get as far as Mars, let alone far enough away to save us from any global warming.